All right. So it's 11:35 or 9 a.m. in Indian Standard Time. We're going to start this session. Hello to everyone. Uh, just put something on the chat about last week. Did you finish your CRUD um, project on AWS? Anything about that? And today we are going to cover Gen AI and the Gen AI services on AWS. Also, if you are aware about Gen AI services on AWS, just put that on chat saying, "Oh, I know about AWS Bedrock, which is basically used um, to create Gen AI applications." If any one of you are aware about LLMs, knowledge bases, agents, foundational models, Bedrock, just type a message. But in this session, we are going to cover um, the Gen AI, the overview of it. Like in today's world, it is taking almost a lot of bandwidth and space in technological domain, and almost every workload or every enterprise is embedding Gen AI into their applications. So it is becoming more and more um, used by almost every industry, every company, every product, every service. And to fulfill that demand, or actually to create that demand, AWS has created certain services um, which are aligning with today's landscape of what is required um, to run a Gen AI workload in cloud. So we will cover that, a little bit of history about Gen AI and how it came into this this space, and what what do we need to learn about it, and also how AWS, how you can use AWS to implement some of those Gen AI features. So we're gonna cover Gen AI as a as an overview. Then we will get on to learn about LLMs. LLMs are large learning models, um, which are basically the backbone of your Gen AI. Um, when I say LLMs, they are basically the foundational models which are used to generate text from text, text from image, or image from image, or different type of outputs from videos. Um, so we will cover a little bit about LLMs. Then we will cover a very important feature which is used in Gen AI application. It's called retrieval augment generation. All these terms are going to be important for you all to know, because they are the building blocks of a Gen AI application. Um, then there is something called knowledge bases. Knowledge bases are another important feature within Gen AI application space, which are basically um, knowledge bases are the backbone of retrieval augment generation, and they front end these LLM models. Then at number 5, we have foundational models, which I already talked about a little bit. Foundational models are basically um, models from companies like Meta, Amazon, Anthropic, even OpenAI. Um, GPT is a model. Chat GPT is an application. Similarly, you have models hosted on Amazon Web Services, uh, and they can be accessible via Bedrock. And those models are primarily from Anthropic, Amazon, Meta, Stability, Cohere. I'll get into that um, more when I'm talking about these things and showing what Bedrock is. So that's what we will cover in week 4. Um, and then once we are done with that, we will create as a lab in today's session. We will create a bot, and we will create a bot on Bedrock. It would be kind of an HR uh, agent. What it will do, um, you can feed your resume to this bot, and then this bot can answer questions based on your resumes. So the idea is to feed this bot many resumes, and then this bot can become an HR, which can now talk to these resumes and answer questions from other HRs or other users. So I'll talk about a bot, which is basically an assistant to um, HR, human resources. Um, to create this bot, we will create a knowledge base on Bedrock. Then we will create an agent on Bedrock. Then we will create a bot which will interact with users, and we will use RAG, retrieval augment generation technique, to um, to fulfill the queries from the users. So that's our project today. We will first learn about Gen AI. We will learn about Bedrock. We'll learn about some of these concepts, and then we will create a bot using all these concepts on AWS console using your models. So let's go back to our Gen AI space. Let's go a little back in the history. I'll talk about the um, historical journey of how Gen AI and cloud came into the existence or picture. And if you have any questions, please put them on the chat. Feel free to do that. While I will continue with my session. So it all started with 1983. 1983, the internet was born. Um, I mean, when I say internet was born, 1983 was the first time um, when first two computers interacted with each other um, using TCP/IP connections. And that made the way to creation of the internet, because if you can have two computers interact with each other on TCP connections, you can now make many computers interact with each other over the over many TCP IP connections, and those TCP IP networks or connections become the network, which is called the internet. Then in 1995, basically the Windows were born. Windows, as you all know, is the most popular operating system for a long time. Mac is um, the competitor of Windows, but Windows have still a lot of big presence all around. And Windows came into the picture in 1985. Why I'm talking about it? Because all these events actually stitched together a history and paved a road for Gen AI and cloud. So 83 internet was born, 1985 Windows came into the picture, and 1990 we have got our first web browser. So internet was there, Windows were there, now browser came into the picture. When browser came into the picture, which means you can now access other computers, other servers over browser using HTTP, which was a revolutionary thing to happen on its own. Then in 1994, Amazon was founded. Um, Amazon started selling books. And why Amazon came into the picture? Because of the internet. Now you have the internet, so you have the browser. You can have users who can come onto the browsers and buy, sell stuff. So Amazon started selling books in 1994 because of internet. Then in 2006, AWS was born. Now, you have internet, you have browser, um, you have a lot of web applications, and these web applications can now um, used to create big infrastructures like Amazon or Google, and they can serve millions of users doing many million transactions every minute, every hour, whole day. Now, because of this scale, of course, Amazon figured out a way to handle this scale, right? So this scale was handled, and while handling that scale, a way to manage such vast infrastructure was devised. Like if you have to manage millions of transactions in a very small period of time, you need to have an infrastructure which can grow, right? You need to have more and more servers added um, onto your compute so that you can respond to that many requests. So if the Amazon's transactions are going um, up and up, the infrastructure was also becoming good enough to handle those transactions. Now, when Amazon or any other company of that magnitude figured out a way to serve that much traffic on the internet and do those much transactions, the natural way of now managing that kind of infrastructure was natural way of managing that infrastructure need to be abstracted, and that's where the AWS was born. Instead of Amazon using this big infrastructure for only their own workings, basically they basically founded AWS and started other people or other companies create infrastructures um, using AWS. The first service which was born was simple queue service in 2006. Then in 2015, OpenAI was born. OpenAI is a company which brought Chat GPT um, to the world in 2022, probably. Um, And the parent company of ChatGPT, which was called OpenAI, that was formed in 2015. So these are some of the events which, progressively influenced the advancements of technology in Gen AI and cloud. So internet came, Windows came, browser came. When browser came, Amazon was born. When Amazon did work for 10 years, AWS was born. Now the cloud came in. And what is the advantage of cloud? The advantage of cloud is you can spin up big environments very easily, and you can manage the traffic, um, which can scale up and down very fast and can um, um, handle peak moments in the journey of um, that traffic handling. So now you have a cloud which can handle the infrastructure without hassles. So because of that uh, freedom, many companies started becoming more and more innovative and scaling because they have now cloud. and 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 the Gen AI or AI is direct result of the computing power, which was becoming very, very easily available. And you know you don't need much expertise to get hold of that much compute. So lot many companies took advantage, and obviously because of that much computing power available easily, it became easy for Gen AI. Of course, the research on Gen AI and AI was going on forever, for a long time. um, but when you now got the almost unlimited compute, your acceleration towards real Gen AI became very quick. And that is why OpenAI was born, because of computing power. But the things didn't just stop there. That was just the start of um, you know the research within AI meeting the advancements in compute, and both aligning with each other and creating an ecosystem which is easier, which made creation of Gen AI applications easy. So that's what happened in 2015. Then in 2017, Amazon AWS released um, another service which was called SageMaker. So SageMaker is a service which can be used to train customized models or create new models, use training data and keep training those models. So SageMaker is a kind of a development platform for AI applications. Um, and one of the AI application, the first of the AI applications are Gen AI applications. Gen AI applications are primarily um, taking the center stage for the last couple of years. Many more applications of AI would come in future, um, and we will finally reach to uh, AGI, artificial general intelligence, from Gen AI, which is generative AI. So, you know, 2017, Amazon SageMaker came. Then on 2022, OpenAI released ChatGPT. And the ChatGPT was basically an application from OpenAI, right? Um, what did ChatGPT do? So ChatGPT is basically a um, it's an application of generative AI. The prime use case of ChatGPT was um, generating text from text. So basically, it can figure out what are the upcoming text based on the input given to it. So it can guess what can happen next. So basically, ChatGPT was a service which was working on underlying LLMs, which were called large learning models. The first use case of AI was um, interpret the language. So, so you give a text to ChatGPT, and it will tell you the answer. Most probably, that answer is um, what can happen after you are asking something. So it will it will query LLMs which are trained on um, data available over the internet, data which is stored all around the World Wide Web. And these models are trained on all the text, all the books, all the newspapers, all the artifacts which are available on the internet. And now, underneath these LLMs have neural networks. So all these Gen AI applications, they are built on neural nets. Neural nets um, are the mimicking of how our own mind correlates patterns and find out um, the responses. Like your mind is basically fire. Whenever you see something, it will recognize that thing or recognize that image or video by recognizing the patterns stored inside our own brain. And our brain is made up of neurons, and those neurons are connected via neural networks. So brain basically understand the patterns, and those patterns are stored in these neural networks. So there are billions of neurons in our brain which kept firing when we ask our brain to do something. Like if you ask what is a dog or what is a cat, how does your brain know what is a dog? So basically it has created the neural nets which will understand what is the meaning of what is dog, and what is dog is also be stored in those patterns. So it will fire those neural networks and find out what does a dog look like. That's how your brain basically interprets uh, the language and make impressions out of the language and find out the meaning of it. And that's how the languages work. A particular text, meaning of a particular text is same for a particular language, and that's the unified link between two humans who are communicating. So basically, the chat GPT was working on neural nets which were uh, contained in an LLM which was totally text based, right? Chat GPT was text based AI, but later on you got Chat GPT 4, now 4.0. They can do images and very soon the videos too. So so we as a humanity cracked the case of text generation in 2022 when ChatGPT came. Although the crack was done a lot earlier, but ChatGPT just, um, brought the application around text into the picture. So once that thing happened, after that in 2023, Amazon released a service called Bedrock. Bedrock is a service which can provide similar kind of services as OpenAI is providing through ChatGPT. But ChatGPT is based on um, only based on one LLM, which is GPT-4. In Bedrock, you can get many other models. One of that model is actually developed by Amazon itself. It's called Titan Express. Then you also have models from Anthropic, Meta, which can be used to create applications. And to create applications, you need basically an API. These LLMs would be exposed on Bedrock using APIs. So that was a overview of Gen AI. And if you have any questions, please put that on chat. Or if this is making sense, that also you can, tell me. I am going to go to Amazon Bedrock and talk about what is Amazon Bedrock. So as you can see, how do LLMs generally manage images? See, at the end, images are also a a a sequence of set of pixels. No, it is not set of. It is somehow internally for every image. So how does, first of all, how does LLM manage even text? So LLM basically create embeddings or a set of numbers which can map to any text or any image. So an LLM will basically, for every input image or text, it will create a kind of a number which can be placed in the vector index. So everything would be stored in LLM using an embedding and a number. So for every image or every text, LLM will create a number and store that number in itself. And that number will have a proximity to other numbers. So for example, if you give a image of a dog to an LLM, it will take that image. Basically, what is an image? It's a set of pixels, and it's a combination of pixels. And using that combination, the LLM will devise a set of number for that image, and then it will store that set of number in LLM, where that set of number is closely aligned with other set of numbers which are similar. For example, if an image is of a dog is an animal having 4 legs, you know, the number generated would be similar to the images of other dogs, because every dog has 4 legs. They look like similar. So that's how LLM will know this image is of a dog. But how does it segregate um, dogs with cats or dogs with reptiles? So it will, for cats also, it will devise a number which is similar to other cats, but also similar to dog too, because dog and cat are similar kind of animals. But they're very different from a snake or a crocodile. So basically, the numbers generated for different images are going to be different, but very similar to similar images. So this is how LLM generally manage images or texts, basically, by generating the embeddings, which are basically a set of numbers which can correlate to certain other mappings which are similar to the images passed to the LLM. So that's how it does. Um, so how does relativity between images are managed? Like for texts, we have Glove, or we use residual nets to be to maintain meaningful relationship between words. It's the same thing. Um, it's the same thing. For images also, uh, you will create similar kind of numbers which will maintain that relationship. Those numbers can be different. Basically, texts or images, they both are going to be using the similar kind of mechanism to maintain meaningful relationship. And maintaining meaningful relationship is nothing but finding a probability. So basically, LLM is a kind of a vast space full of nets. Um, like imagine quite a huge space like sky, and then there are different stars in it, and then there is a lot of empty spaces between different stars. Um, so basically, in LLM also, conceptually, it is like a vast space with different different small islands of data, and on those islands are based on their um, proximity define whether they have meaningful relationship with them or with each other or not. So similarly, if an image is presented to an LLM will create an embedding or a kind of a set of numbers, and then will put that set of numbers in a particular island, and then based on the probability of the similarity of this particular image and the island's probability, and then these islands are basically based on their proximity, you will find the probabilistic results. So for example, if I feed a photo of a pit bull and ask, oh, what is this guy, what kind of animal is this? So basically, again, the LLM will create an embedding, and then it will find an island which probably is very similar to what is asked. So if that LLM never saw a dog or imagined or encountered a dog yet, probably it will say, oh, it's a cat, right? If your model is not trained enough, then it can, and it knows what is cat, but it doesn't know what is a dog. If you present a pit bull, it can say that, oh, it probably is a cat. But if you train your model enough, then it will be able to recognize a pit bull as a dog. So that's the whole point of Gen AI. As more and more it sees or encounter things, it figures out probabilistic value of their mapping to the relevant data. That's how texts and images are basically stored in an LLM. Um, so what is Bedrock? So you have many foundational models. If you know about companies like AI 21, Anthropic, Cohere, Meta, Mistral AI, Stability AI, and Amazon, all these companies are kind of startups. Obviously, not Meta, but all other are apart from Amazon. They created their own LLMs, which are basically uh, doing things like text generation, image generation, even video generation based on the input prompts. And what Amazon Bedrock does, Amazon Bedrock basically is a managed service which hosts these models, and then it exposes an API uh, which can be used to invoke or run an inference on a model. When I say run an inference, it means you give a prompt to a model and you get a response back. And Amazon Bedrock makes it easy. Let me show you Bedrock in my own console. If you have a console, you are already doing it. You will have Bedrock. To access Bedrock, you need to create a IAM user in your root account. And using that IAM user, you can use Bedrock. So this is my Bedrock console. If you see here, these are the foundational models which I was talking about. It says Amazon Bedrock supports foundational models from industry leading providers. Choose the model that is best suited to achieving your unique goals. So you have Jurassic 2 series by AI 21 Labs, Titan by Amazon, Claude by Anthropic, Command by Cohere, Llama by Meta, Mistral, Stability Diffusion. And once you go to your Bedrock, you need to go to access these models, you need to go to model access. So I already granted myself access to all the models. Um, just keep in mind, all these models can be charged. So when you go into your model access, what you will do, you will say modify model access. So once you do that, then you select which model you're gonna use. Before accessing that model, you need to enable your access here. So you will go to your this setting and say, for me it's access granted. For you it will be no access, and you will be saying request access. Okay, once you say the request access, click the next. I have not made any modifications, but when you do it, you will get access to these model for yourself. So if you see in this page, I have access to A21 Labs, Jurassic Ultra, Jurassic Mid, and then I have access to Amazon Titan Text, Titan Text G1 Lite, Titan Text G1 Express, all kinds of models I have access to. Then I have access to 4 Anthropic models, which are Claude 3 Sonnet, Claude 3 Haiku, Claude. And I have access to Meta, Mistral, and everything. But if you are starting, maybe you can just have a couple of models. You can request for just couple of models. One is you can go for Claude 3 or any Claude text and vision based models. And then you can have, Titan embedding G1, Titan multi-model embedding G1. So you can play with these 2 models. So that is how you access the models in Bedrock. Now, 1 second, I'm going to stop my video for a second and give me 1 second. All right. So so we are now on Bedrock, and we have got access to some models. Let me tell you what we are going to do. Okay. So what we're going to do is we are going to create a chat bot which will use underlying model, but it will have the custom data. When I say custom data, I will feed this chat bot my own resume and ask questions about myself, which means the application will interact with model, but give the context to this model. And that context will come to the model through this RAG mechanism, retrieval augment generation mechanism. So what is that mechanism? Basically, what I'm trying to do, I'm going to ask this bot that tell me where was I working in 2016. And model has no information about me, right? It is not trained on my data. So how do we make this bot work on my data? For that, we will be using retrieval augment generation and embeddings. And what does that actually mean? Basically, we will create a data source. That data source would be having my resume um, into it, which means it will create the embeddings of the text inside my resume and store it in the data source. Then, when it asks the model about responding to the prompt which I am giving, it is going to be first talking to the local data store and get the embeddings, which is basically are the relevant texts from my resume. And then both the query and the text from my resume would be fed into the model, and then model will respond. So let's see how it works. Let's go one by one. First of all, we selected the models. Then I'm going to go to create a bucket, the S3 bucket. Let's say the bucket is named as knowledge base for HR bot. So that's my bot. In that bot, I'm going to upload my own resume. Let's say this is my resume. So step one, what I did, upload, created bucket. Step two, I'm just putting these steps in chat. Uploaded my resume. So now I have got my resume added into a bucket. Let's go to Bedrock. Get started. I'm going to say I need to create a knowledge base. I am going to say knowledge base for HR bot. So that's what I'm going to do. Now it is asking me, what is my S3 location? So I'm going to say that's my S3 and this is my file. So I gave my resume as the data source. Step 3, create a knowledge base in Bedrock. Step 4 is link S3 bucket object in this manner. It's resume with this knowledge base. So that's what I'm doing. It is asking, see, it is asking select embeddings model and configure vector store. So basically what is going to happen is this data source will be converted into an embedding, or the numbers, or the set of numbers which will define where will this text go, right? So I'm going to use Titan text embeddings version 2, and I'm going to say quick create a new vector store. We are creating a vector store where the embeddings for this data source would be stored. So I'm doing this now. Create knowledge base. Okay. And it'll take one couple of minutes to create this. So let's wait for that. In meantime, I'm going to write it on the chat. What is step 5? Step 5 is create vector store using embeddings and embeddings and data source. So what does vector store do? So basically vector store, so when I said that, so I'm answering question from Harsh on chat. The question is, what does vector store do? Vector store is basically a database. If you see, this database is basically vector engine open, Amazon open search serverless. So this, for every LLM, LLM stores information in itself. Give me 1 second. I'm back. So LLM basically stores information using numbers. And here we are creating a knowledge base which will store the context. And what is the context here? I am passing my own resume. So this resume will be converted into different chunks of data, and those chunks will be converted into set of numbers which are called embeddings. And these embeddings needs to be stored in certain databases. And that's what vector store comes into the picture. Whatever my resume is, it will be converted into embeddings, which will be set of numbers, and those mappings between the chunks of text and numbers will be stored in vector store. That's what vector store do. It will contain the embeddings for the knowledge base. So my knowledge base is created. I'm going to select the knowledge base and say sync it. So it's going to sync the data between knowledge store and knowledge base. The sync is completed, which means this knowledge base can be tested now. Remember, I told you that the interaction between user and the model is via Bedrock. So here, if you say, it says, I can test my knowledge base. And it is asking, select a model. So I'm going to select a model. Let's say I select Claude. I select Claude 2 on demand. I say apply. So after this, my knowledge base has been connected to the data source. And then my knowledge base is created. And here I'm testing my knowledge base. And Bedrock provides you that kind of environment where you can give the prompt. Here I have, if you can see my screen, yeah, you can see. I'm going to run. I'm going to put something here. I'm going to ask, what does Amit do? I'm going to say run. So see what happened. It gave me the answer. It says Amit is a security architect at Amazon. He leads something, implement comprehensive security strategies, builds and leads high-performing security teams, champion secure cloud architecture principles, lead GRC, etc. It told me what I do. It basically get this information from my resume, which I fed into S3. So now this is a very, now I'm going to do one more thing. I'm going to say, don't generate response. What does it mean? It is not now going to any model. I'm going to test this knowledge base itself, which is connected with my resume. Let's ask the same question again. What does Amit do? Now see what it did. It, 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 it returned me the chunks of like five things, right? It gave me 5 different numbers and it gave me very raw information about what I do. So these chunks are just the text from my resume. There is no response generation happened here. So it went into knowledge base and it fetched this information from my resume. But when I say generate response using Claude, it will do different thing. Once I ask that question, it gives all those chunks of data to the model, and model creates this response, which is a very formatted, summarized response. So now I have a bot, which is basically connected with a model and having knowledge base and using RAG principles. to give me the responses. So I'm going to put these steps again in the chat. Step 6 is, after creating the vector store, uh, test knowledge base using generate response. Step 7, test knowledge base without using without using generate. So that's how you will basically create a knowledge base. Now, just knowledge base is not going to be enough. To have a full-fledged bot, you need to create agents. Imagine, this bot needs to talk to some APIs to get more information. Like if I ask, oh, tell me what kind of jobs are available for Amit. So to do that, it can call some API, basically getting some key skills from my resume. Let's ask this question. What are the key skills of Amit? So basically what I'm doing here is I'm saying, see, I'm asking the model, uh, what are my key skills? So it gave me all the things I know. It just parses the resume, figures out the skills, and give it to me. So basically, if I have an API which can take these skills and find me the jobs across the locations and then automate whole of that process, and that will become a full-fledged bot. So now I got my skills, but to do that you need an agent or a functionality within this bot to call other APIs, right? And those APIs can return you the data, which you can enrich and get the response, and and make sure that this bot becomes like holistic, full-fledged bot. So now let's go to something called agents. Let's leave this knowledge base for now and go to agents. Let's say I'm going to create an agent. I'm going to say my HR agent. This is an assistant to head of HR. Okay. Let's create this agent. I'm going to say you are using Claude 2.1 model, and instruction for the agent. We need to tell the agent who you are. You are an HR assistant, assistant, assistant. You are an HR assistant who has knowledge base where all the resume of candidates are fed in. Your, your job is to respond to the user and enrich his experience. So that's what we are building. We are building an HR assistant. So action groups, I'm going to add action group here. In the action groups, basically you can add the APIs, you know, an Amazon Lambda function will be created in your account on your behalf, no further configurations. So it is basically what will happen is, yeah, this action group can invoke a Lambda function, which can give you, which can basically tell you the jobs available for a particular key skills. But I'm not gonna basically use that here. I'm gonna say, because I don't have API, we can do that. But for this session, we can just skip that. I'm going to say return control, which means agent responses in the test window will prompt the user for the function details to generate a response. So that's what I'm going to do. And I'm going to create this action group. What happened? Validation functions. What is this function schema? Okay. So let's go once back here and say HR agent. I'm going to add it in space. Action groups. I'm going to say, let's say I'm at Sinfo. So now we are creating a action group and an agent. We are going to give the knowledge base, which we already created, knowledge base for HR bot. And what are the instructions? Knowledge base instructions for agent. This is a knowledge base which contains the resumes of candidates. Agents can interact with these this knowledge base to enrich their functions. Okay, I need to save, save, and then add a knowledge base. Okay. So once that happens, my knowledge base is added. And at this point, I'm good. I'm going to say save and exit. Um, that's my agent, which is now connected with a knowledge base. And that knowledge base is connected with the data source. Now let's say prepare. Uh, Agent instructions can't be null. Okay. Okay. I need to give in you are an HR assistant. Your job is to interact with the knowledge base and respond to users' queries. Save and exit. Now I'm going to prepare it. So I made the agent. I told the agent who you are. I created an action group, created a knowledge base. And my agent is here. So let's see what can I do with the agent. Um, can you tell me where Amit was working in 2016? So I asked this agent a question, and it is now working on it. So if you see, can you see this? It says Amit was working at JP Morgan Chase in New York City in 2016. So it came up with an answer. You know, let's say what happened. So if you see, this is what happened. There are three types of things which happened in first phase. It was pre-processing trace. So let's say what happened in the first step. In the first step, see it says that you are a classifying agent that filters user input into categories. Your job is to sort these inputs. In the first step, it figured out, it created an agent which can do certain things, and basically, and that's what was done by the model. Based on what I told, it figured out what this agent is. So then it asked the user input is, can you tell me where Amit was working in 2016? That was the input. So now let's see how it reached to a conclusion. The first thing it did was, let's analyze the input step by step. The user is asking, can you tell me where Amit was working in 2016? Then it inferred, this is a direct question asking for information about where someone named Amit was working in a specific year. The question does not seem malicious or harmful in any way. The user is not trying to get information about the agent's function or manipulate the agent. So basically, it's figuring out whether the question I'm asking is genuine or not. The question could potentially be answered by the knowledge base function the agent has access to if it contains employment history information. So then it referred to knowledge base. Um, and then it figured out that possibly this question can be answered by the knowledge base. That was the pre-processing step. So basically in pre-processing trace one, the whole process was to figure out how can this agent or how can this bot answer to this particular query. And it figured out that, oh, I can use the knowledge base. So now next step is orchestration and knowledge base. So now it went into knowledge base. Now see what is going to happen. Again, it is, you are an HR assistant. Your job is to interact with knowledge base, this and that. Um, then it started figuring out what I am asking. So it says user has asked where Amit was working in 2016. To answer this, I will invoke the knowledge base search tool. So it will basically invoke the knowledge base and searched my work history. And while doing that, it took all of my resume, um, and then um, figured out, um, it took my resume and then first it chunked into different location, different texts. So if you see, the first text was bunch of lines, and then the second text was again bunch of lines, third text was bunch of lines, then again bunch of lines. It divided my resume into multiple chunks. So once the chunks were done, then it did step 3. Again, the same story goes on. And here, it is asking knowledge-based response generation. In step 4, basically, it used all those things. See, Amit was working at JP Morgan Chase in 2016. It used the text and generated where I was working in 2016. And that's how the bot was able to answer the questions about myself. So that was the knowledge bases and agents. What I want you to do, um, I want you all to also create a HR bot on your resume. Um, and do these kinds of queries. So you will be creating a bot like this, which I created. That is your this week's tasks. And in that bot, you will be using your own resume, and you will create a knowledge base and an agent. And then this agent should be able to give the answers based on the information stored in your resume. So that is what I want you to do in this week. I want you to explore Bedrock, um, create a knowledge base, create the agent, and do these 10 steps, which I put it on the chat, and create me an HR bot. I'm going to again put these steps in detailed manner on WhatsApp and put this video on YouTube. I think for today it is good enough. But I want you to go through it and tell me if you understood and you are able to use Bedrock and create these bots for your own self. Um, that would be a great assignment to basically do in this internship. Um, you get to know about Gen AI and get a feel of Bedrock and all other functionalities. Um, any questions? If not, let's conclude this meeting now and build these things up for this week. And and let's connect next week again to figure out your progress. Um, I'm going to conclude this session here and going to be talking to you soon. But if you have any questions, please feel free to bring it here. Oh, great. In real life scenarios, where does Bedrock will be used apart from this example? So this example is just a very realistic example. In real life, Bedrock would be used to create applications which can be chatbots. For example, imagine you are a insurance company. Um, you have many policies, many insurance policies, which is available to you. And now you got a customer service representative whose job is to talk to users on a chat session and respond to the questions of users. Right now, there are like maybe millions of users who bought insurance from this insurance company, and they are constantly chatting on customer support. Now, the agent who is responding to these users would be smart enough, quick enough to go through the policies and get the real answers to the users. And imagine in that case, all those policies can become a knowledge base. And the agent which I built today, the HR bot, can become an insurance agent. If I say, oh, you are an insurance agent, here are all the policies, and now start responding to the people. So in a real life, Amazon Bedrock can be used to create applications such as chatbots, which can be used for commercial purposes on a scale to respond to users' queries. And not only a customer support, but actually it can act like a whole salesman. Like imagine if you give all your catalog of your retail shop um, to knowledge base of Amazon Bedrock. And then on top of that, you create an agent which can interact with this knowledge base um, and respond to users' queries, or can buy or sell things for user. For example, user can say, oh, I need to go to a hiking trip. Can you suggest me a shoe which is efficient and cost effective for my trip? So these kinds of queries would be answered by the bots, these kinds of bots which are built upon Bedrock. using these models. So the example I shown is just a sample, but this app can also be scaled for real HR solutions. So yes, a Bedrock would be used to create real life applications, chatbots, summarization. For example, a if a medical assistant is reading the medical reports and trying to create summaries, the Bedrock can be used to create applications which can take all that text and create summaries fast. And if you take this from text to images, then again, you can use Bedrock to create multi-modal applications which can interact with text as well as the chats. Sir, Bedrock is chargeable. Gautam is asking. Yes, Bedrock is chargeable. When you enable a model, that's why just enable only one or two models which you need. And when you enable and use the model, the you will you there will be a cost involved. Sir, even the AWS Lex, yes. So Lex is also a chatbot. Can be used to create a chatbot. The edge with Amazon Bedrock is it can have foundational models. See, Bedrock is not in itself. Bedrock is nothing. Bedrock is just a service, but underlying you will have different models. These models, like Claude or Meta, these models are used for different kind of functions. Like for example, models from Meta can be used to chain the thought process. Like it will divide the task into chain of thoughts and process one by one, while the models from Claude can just be used for text generation and summarization. So the fun or the essence of using Bedrock is basically you get the access to so many models. And Bedrock is basically a platform to create GenAI applications. Using Bedrock, you can also use Amazon Lex. The agents on Bedrock can orchestrate the workflow. So the edge is in having the whole platform, which is built on models, and there are agents on top of it. So all the concepts which require to build a Gen AI application which is extensible, Bedrock can fulfill that. You can use Lex for creating chatbots and other applications, but Bedrock is basically when you go in the commercial environments, the companies which are working, they will be evaluating models on Bedrock. They will be bringing models from SageMaker to Bedrock. And all that whole holistic functionality, from evaluating, from testing to creating chatbots, are done on Bedrock. So it's a platform. And if you go a little further, there is something called Bedrock Studio, which is available now in preview, which is basically kind of an IDE, like 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 a you know Visual Studio Code for Java. So Bedrock is for holistic creation of Gen AI applications. Hope that answers the question, Abhishek. Awesome, great. Um, any more questions? If not, then awesome, guys. You need to now create this chatbot as your assignment, and I'm going to talk to you next week. I'm going to put the details about video in the chat. And uh, thank you. Thank you, Dulari. You're welcome. Thank you. I'll talk to you all next week, guys. Bye bye.